Hi guys, welcome to Design Technology TV. Today we are going to be looking at another video in the series for the NEA for the OCR specification. Today we're going to be looking at 2.3 Development of Final Design Solutions, 3.4 Quality of those solutions, and 1.6 your Technical Specification. So in terms of the Final Design Solutions, what we're looking at is strand 2.3, and you are looking to make sure that your key requirements that you wrote as part of your brief are covered in full. So throughout the design process, we should see you resolving the issues surrounding that and making it so that you're meeting those requirements. And there should be some clarity of that as well, so that we can see that this is a product that is suitable for real world production in a factory in real life. Importantly, as you go through this, if your key requirements have changed, so for instance at the start you might have said that your product needs to do a certain thing, but that's changed because you've realized through the design process that it's either not feasible, it's not marketable, or it doesn't suit the product as it's going through the iterative design process. It's fine for those key requirements to change as long as we can see that happening as you go through the design process. There's no problems with that at all. We should also see clear progression. So you're iterating your designs as you go through. We should see a wide range of models and development, and that can be in any form. So it could be anything from modeling as cardboard or plastic or wood, or it could equally be development through sketch development, CAD development, or indeed things like other software packages where you're using things like Circuit Wizard to show circuit diagrams, etc., etc. But the progression should be clear. We shouldn't get to the point where you have your final design which suddenly pops out of nowhere and we have no understanding of where that's actually come from. What we need to see that you're building towards that, and it might be that you try different routes and they get shut off at different times. That's absolutely fine, but it shouldn't be that we just kind of have, here's a design, here's a different design, here's a different design, oh, and here's my final design, which is nothing like those previous products. That doesn't work very well because it doesn't show that progression. It's going to reduce your mark in this section. Fundamentally, though, you have to have a final design. We need to see a proposed final design for strand 2.3. You could choose not to do one, but then you put yourself in quite dubious ground in terms of saying what is your actual final design. The other thing to say as well, if for students who run out of time, it's not ideal either, because quite often what happens is they label a product randomly as final design and they lose marks in other sections. So you want something that's separate, that is definitely a final design, and we can see that with some clarity. The easiest way to denote that is write final design on the sheet. As always, we're looking at the mark bands here. We're looking for comprehensive progression, so we can see there's lots of detail, lots of progress from earlier developments. You've identified the opportunities, i.e. the things that your key requirements need you to do, and you've met them. So if there's been problems that needed solutions and resolving as you've gone through, you've identified them, you said this is an issue in your next steps, and then you've worked your way through and you have met those requirements to have a fully functioning design that has resolved all of the issues that are in hand. Within it, we're going to see lots of detail in terms of the development as you work your way through, and it's going to be right the way from your initial ideas right the way through is all part of this, as it all leads towards that final design. As we've talked about already, identifying the problems and opportunities and resolving those as you go. And then also we need a final design solution that satisfies all the technical and non-technical requirements of your product, i.e. that we understand how much it weighs, how big it is, what it needs to do, how it's going to function, how it's going to do those things to be a successful product. Common mistakes where we don't see a final design or where they just suddenly pop up from nowhere, as I've already covered. That is not a good way of having a final design. If it has no or very little relationship to the designs that have come before it, it's almost like you've missed out a whole section of the project. As always, not going to cover these in massive detail, but we should see that you've got a systematic approach in terms of next steps as you work your way through, refining, defining those problems to get the higher band marks. As always, real-time evidence, so photographs of the models that you're making as you go through, a proper final design that is suitable so that it can be looked at by your stakeholders. Indeed, the final design is your last opportunity really to get feedback from your stakeholders before you embark on any prototype manufacture. We also want to see that you've got clear progress through this so we can see the decisions you're making. It shouldn't just be that we're trying to guess what you've done. We should see the processes we've gone through, and I'm going to show you some examples of that here. So you may have already watched the outstanding video. So this is the same content for there in terms of this particular section. It's one section taken from it for the design of the foot. If you've seen that video, you've already seen that there's a breadth of all sorts of other component parts. This is only a section. But what you can see here is we've got the initial ideas up in the top left-hand corner, and then we've got some basic models and some consideration of how that might work. We then got good and bad points that are highlighted, so the student is highlighting what they are, and then they are then working their way through to improve it with feedback coming from a client as well, or a stakeholder. The model then trials different things, and they try different things. Now, for me, arguably there is more written content here than I would think is necessary as you progress your way through, but it was the chosen style of this particular student, and it's not a bad one. It's just not what we'd normally see in terms of a real life design process. There probably doesn't need to be so much. However, the content that is here is, there isn't any waffle. It's entirely focused on the design that's happening. Because of that, it means that it's all relevant, which means that although there's quite a bit of written content, rather than it just being pointless waffle, it actually generates marks because it is so focused. You'll also notice that the yellow box on the right hand side says completed. So they've talked about what they've done and then next steps. What are the next bits that need to happen to make this a successful product and to meet the key requirements? We then get into the next section, where again we look at different options in terms of how the product might work. It would be nice here if we had a little bit more clarity as to what the key requirement was that was being resolved. That could be a little bit clearer, and that could just be a single sentence or a reminder of what that key requirement was that is being resolved, or key requirements if there's several in these slides, just to give clarity to the moderator so they can understand and see what's going on. Again, it then goes to the next step. More of the same. So we're just going to go through the whole thing here in terms of the different steps and processes. And you can see this model has now been added to. There's more detail in it, and it's adapting and iterating as it goes. We can see the progression that is undertaking from the very original idea to where we are now. Again, we've got these next steps. We've got the good, the bad points. There's less bad points, as you probably noticed. There's still improvements that are being identified. Again, what is the key requirement that's being focused on here? That'd be quite useful to know, but other than that, it's spot on. A bit of sketching to identify smaller component parts. We've seen this before in the outstanding video. You probably have. If you haven't, then I suggest you watch that after this. And here we've basically got component parts where we're seeing them sat in position, but there's a real understanding of what is being resolved and why the pieces are being put in place. Some playing with those particular design aspects, trying to work out how they might modify and adjust the foot. And again, modifying and adjusting the toes. We've got some details coming in terms of how big children's feet are, because obviously that lends itself to them being able, the child being able to wear a shoe over the top of this, or indeed making sure they've got enough stability and equality between both of their legs and feet. Then looking at weight transfer, so really considering how that might affect walking, and then what component parts may be brought in to fulfill certain roles. There is no requirement for you to design every single component part, and no manufacturing, no product designer would ever do that unless they absolutely had to, because it's much easier to buy components off the shelf. So if you have bought in components, have a look at them, find some, talk about which ones are the relevant ones to the design that you are undertaking. We then get to the last stages of the foot development, where we now have a more complicated design. We can see all the component parts, we know how they fit together, and then the structure of the design is and what it's going to look like. A bit more stakeholder feedback, and then they start going even further, where they're making newer, more models that look in even more detail about how the product is going to work. Again, what are the key requirements being resolved? That's not totally clear, but we can definitely see there's very clear progression as we're building our way through. And then more detail, more functionality, more component parts. And fundamentally here, what we're looking at is something where we're seeing real clarity in terms of what the product needs to do in terms of its component parts to be a product suitable for real world, real life manufacture. Into a different product. Now, this one I've sort of removed the slides that came before it, so kind of what we've just gone through. What you're looking at here now is the actual final design proposal, and there's a series of parts here which are put in place to show a third party what the product would be. Obviously, I'm not doing the same again with the outstanding because you've already seen it. So it makes sense to do a different one here. Here, a slightly different product. This one is a leg brace product. So for OAPs, and with some, it had an adjustable motor and various other bits and bobs built into it to help the user raise their leg. So it's quite an engineering style project. At the final design, we've got a final design sketch. Now, final design sketches are often used poorly. This is quite a nice final design sketch because the quality of it is really high, so we can see the product in situ. It's also not the only thing that's done as a final design. So if it was on its own, it probably wouldn't give a third party who was looking to manufacture this as much detail as they'd want, which would then obviously affect the marks. However, as it's part of a series of slides you're about to see, that's absolutely fine, and it's a real showcase of quality and skill here. So this student was very adept at sketching, but also was good at using things like Photoshop. So they photoshopped a sketch to add color into it, which gives it this very nice polished appearance. Within the final sketch as well, they're also writing how it's meeting certain aspects, and some of those key requirements that were written at the start of this project were the fact that it needs to be comfortable, that it needs to look aesthetically good, that it was user friendly, and that it would be fit for purpose in terms of its function. So you can see here straight away the student is carrying through those key requirements and is showing how they've met them as part of their final sketch. In addition to that, then we then have the model itself. Again, it's been done in CAD. CAD is by far the strongest way that you can undertake these sections because it gives you so much opportunity to showcase your skills, do exploded drawings, and do a variety of drawings more quickly. The CAD itself often takes quite a long time, but once you've done it, it then allows you to do things here as part of your final design to explain to a third party. Equally, it's also really useful for you to use when you come to do 1.6, which is your technical specification. So it cuts your workload overall and gives it a very professional finish. So here then the candidate is then looking at component parts, referencing earlier work as well as he's gone through. The product as a whole, so again we're seeing all the component parts and how they fit in relation. So this is really useful to convey to a third party how the product would actually be assembled. Quite often if you only show them an assembled drawing, there's lots of details that are lost or missed and therefore are left to be questioned. That's going to affect your mark. So you want to make sure that the clarity of your communication in showing all component parts is there. Then we get a sort of technical design like final poster. So the poster is on the right hand side. It's well laid out. We can see what's going on. It's got some aspects of advertising to it in terms of it's designed as an advertising poster. That's going to fit into marks that are found in your marketing section. So this is an ideal section to do that. You'll also see that the man has been photoshopped into it to show how the product might be used. And again, then we then look again at some of the key requirements on the left hand side, and we're talking about how the product actually meets those, so the key features of the product itself. 3.4. So here we're looking at the quality of the final presentation drawings. They should be professional in terms of their standards. So what we've just seen in terms of the poster, the technical poster we've just looked at on the previous slide, is a really high standard. I'm going to show you some more examples of that in a moment. It should have clear layout. It should have some annotation. The amount of annotation you put in is your decision, but it should be focused on the design requirements or the marketing aspects, one of the two. It shouldn't be War and Peace because the images themselves should give over the information we need. It should be clear to a third party. So a third party is somebody such as your teacher or your demonstrator or possibly your stakeholder. So they can look at it and they fully understand what the product does, how it works, and what your final design is. As I've already mentioned, CAD is the strongest media by far because also it allows you then to add in things like exploded and section views very easily. You could do these in sketches. So although CAD is the best way, it's not the only way. So if you don't have access to CAD, then it can be done with exploded and section drawings, which are hand drawn, but you've got to bear in mind that you are battling against the quality that can be seen in CAD drawings with full renders while you're doing that. So in terms of the quality of what you've got to do, you've really got to make a step up in your quality and really push and hone your presentation drawing techniques if you're going to access the same higher marks. As I've already mentioned as well, it's a good opportunity for you to show your marketability of your product. Do an advertising poster because it links into the viability of your design to show that it could be sold. It's also an opportunity for you to showcase how good your skills are. So you can really show off and put some really high quality presentation here. We're looking at the it's a formal presentation drawing of the design solution. So you might have component parts that are all part of the final design solution that are built in together. It should be impactful, so it should really kind of show quality and stand out as being something that has a bit of a wow factor as much as anything. And as I said before, it should be suitable for a third party who knows something about designing of some form, or your teacher. Likely content: CAD, exploded models, formal models, so they can actually be models that are actually built. So instead of having a CAD drawing of a component part, you might have actually constructed and manufactured that to show that it would work. So you could actually move it and close it or open it or whatever you're doing and show it in motion to prove that the product could work. So you can do that. Those can also often inform part of your final prototype as well, as that's kind of a model that leads on to your very final prototype. We can have videos and audios. We can have looking at working models, so they're actually happening, testing. We can also have rendered images, if you've already seen, and it's probably the focus of the way we normally see it. We can also have images that are done in Photoshop and various other ways to allow you to do it, including as well marketing aspects, which will include packaging and branding too. Those are not essential, but they're nice to see, particularly as they feed in, as I said, to the marketing or the marketability of your product. Common mistakes: people don't get final feedback. They just do the final design and then they plow on, and they find out later on when they do their final evaluations that things could have easily been changed and updated according to your stakeholder and been a better product. Or the communication to stakeholders is a bit weak, i.e. things are missing, or there's component parts we can't see, or we only see a design of the whole thing put together as a single part. We don't see the construction of the small components as part of an exploded drawing. That's an issue as well. It's particularly a weakness of sketch final designs, where students often embark on this, do a really nice sketch, but we don't see all the details that you would normally see in CAD, and then that means that the clarity of communication is weaker. And again, people don't necessarily look at the marketability of the product or use it as an opportunity to show that off. So showing the viability of design means that it's suitable for a third party, that it can do the things it needs to do, and having enough impact and then quality techniques going through it to show off your skills. So we've got a design here. This is for an architectural product. It's actually a flood defense building that would float. As you can see, CAD's been used very nicely to do it. The layout of the sheet is really nice. There's also, if you look in the bottom right hand corner, you can see some of the sketch work as well. The quality of the student has included that as well because he was so good at sketching. It's a really nice sheet that shows component parts and how they might work, and there's also then the key features that you can see with the modular dock system and the frictionless guide wheels. This one doesn't have as many key features up on the top left hand side, but it's nicely done. You can see we've got consideration of branding. We've also got a very, very high quality CAD model. This CAD model is obviously then exploded into its component parts, and the candidate went on to 3D print most of these aspects. It's a lovely bit of CAD, technically very difficult, quality-wise very high. It took him ages to do, something to bear in mind with CAD, but it's a lovely bit of work that really showcases what you can do if you put the time and effort into this section. We've then got this one, which has then been rendered effectively, so it's actually a render rather than the final product. We've got a marketing style poster of it, and then we've then got another poster which shows all the component parts. So again, our third party can engage and understand what the component parts are and how and where they fit together. This one's not, in terms of quality, isn't the same. It's a lift assist product which allows or helps people get in and out of seats. These products could have been rendered at a much higher quality, which would have improved the aesthetics. So the quality here is lower. The layout isn't as nice. It's not really selling the product as well as it could, but we can see the component parts. What's nice is then this, which is then showing all the component parts. I don't personally like the multiple colors, and I don't particularly like all the arrows all over the image, or indeed the quality of the image, which is low. However, as a way of showing your third party how the component parts fit together, this is quite a nice way. This one, a crutch project, a prosthetic leg project, different from the one that you've already seen. This one then has There's not so much detail on this particular slide. There were several slides of the final design that showed it and the component parts and how it fitted together. The CAD also isn't as sophisticated as the stuff that you've seen elsewhere. However, what's nice here is the branding and the fact that it's used as a marketing opportunity, and we can also see how this product would be shipped and sent to the user, at the end user, in a third world country. The whole idea being that this product would allow amputees more ability to have a product of this nature in an environment where they're quite rare. Okay, finally, 1.6. So this is your technical specification. Mistakes are made here that often, because it is 1.6 and it follows on from 1.3, 4, and 5, people then go, okay, I'm going to stick it at 1.6, so it goes at the start of the project. It is not something you do at the start of the project. You don't know the answers to this, so old school design and technology courses, what they would do is they get you to do and write a specification at the start of the project, and then you would try and fulfill it. That's not real life, and that's not what we do here in this qualification. 1.6 comes after you have done your final design. So you've gone all the way through your design process, you've got to the end of that, you know what your final product is, and 1.6 then is you stating what the product actually is going to be, how it's going to work, and how it's going to be manufactured. It's based entirely in real world, so we should be looking at you manufacturing it in real life in a factory setting. So you should be looking at DFMA, you should be considering all the component parts and relevant manufacturing techniques and bought-in components that are going to happen to make this a viable real-world product. Again, the detail here should present well to a third party so they can actually understand it. The way you can think about this is, have I given enough detail in this section to just hand my project to someone who knows what they're doing, your teacher, and then say, right, make my product, see you later. So in other words, you just walk away and they should have enough detail from all the stuff that's in this section to make your product from start to finish with no problems whatsoever. We're also looking for accuracy and detail, so detail of all the component parts. You've seen some examples where you can see everything down to the small springs within the components constructions. One of the ways to do that is through orthographic drawings. If you've built your product in CAD, not only can you render it as part of your final design solutions, but you can also use it here in 1.6 to then do orthographic drawings. It is also an opportunity to look at wider issues. Now, they're marked in 5.1. However, they're often something that gets missed, and Strand 1.6 is actually a really ideal place to pop them in. And you can look at things like sustainability, social, moral issues, and other wider issues that are associated with your product and the impact it may have on the wider community. High levels of accuracy, make sure it communicates well with third parties. It's going to be formal drawings, so orthographic drawings and assembly drawings, so we know how they're put together. We've also got details of any bought-in component parts, enough information so that we know how the product works and goes together here. And then you might also look at quality assurance and quality control considerations, which may also include tolerances, manufacturing techniques, etc., in more detail. Common mistakes, as I've said, people put it in the wrong place because they think it should go at the start because it's marked, or officially it's in the strand 1, so people put it at the start of the project. It's not. Remember, this is a chronological portfolio, so it should come after your final design. People do not focus on real world scenario, and they talk about manufacturing the product in their own workshop. That is the wrong approach. It should be a real world approach, not a workshop approach. You're going to do a plan for production, i.e. in your workshop. So as that's the case, this is not done in this section. Third parties should understand what the outcome is. And as we've already mentioned, this is your final opportunity to get feedback from a user at this stage before you then progress into your prototype assembly. CAD's the best way by far. It can be done using other means, so you can do technical drawings by hand, but they often take quite a bit longer. Obviously, if you don't have access to CAD, then that is obviously a route you may choose to take. We should be reflecting on industrial and commercial practice from start to finish. So make sure that it is focused in factory settings rather than else. You also may have a master list of things that it has to do because you started off with your key requirements. Are they still the same? Does it still meet those? Have you shown that it's met those requirements? So going back to our outstanding example again, we've got the entire product in its entirety. We then have a series of sheets, which I'm going to go through fairly quickly, which show all the component parts. What would have been nice here is if those component parts were actually lettered or numbered so that we knew what they were. This would be useful elsewhere later in the project in terms of both the plan for production, but also in terms of the cutting list, which you're going to see in a minute. So all the component parts are just pulled apart from one another, and then they then go put onto an orthographic sheet. You'll notice that on most of these you can read the dimensions on them. If you're doing this and you've got quite a large part and the dimensions are lost, or there's lots of small dimensions, it may be that we can't read all the dimensions. As someone marking it, we will give you the benefit of the doubt that they are there and they are correct. As part of this, then, this candidate then is then looking at 3D printing. The product would be 3D printed on site. So this is completely relevant to the industrial process. So what the plan is to send out a series of component parts and then 3D print on site. So we're talking about the printer, the appropriate materials, how this would work, and then advantages and disadvantages of actually manufacturing it on site. Consideration of DFMA again, working their way through. Remember, the senior moderator, he loves DFMA, so make sure you get it in throughout your project. It should pop up fairly regularly. So this is then looking at how the product would actually be used with scanning technology to make sure that the part, in terms of the cup, fitted what it needed to do. We then look at the pylon, and there's some detail about how the pylon may be manufactured. So looking at investment casting for the pylon, there are different options depending on obviously what you've done and how you've designed your product. So there may be here options in terms of this is one option, but this is also a suitable option as well. Talking about standardized manufacture, the moment you're doing that, you're reducing the costs. Again, then, as I said, there's an opportunity to bring in wider issues. So looking at economic, social, and environmental impacts that your product may do or present to either the user or the stakeholders. Then looking into how something might be stitched. So there's obviously component parts within this design that need to be stitched, press studs, bolting components, etc., etc. So we're also looking at how the material might be weaved and manufactured. Then at the end of this, the cutting list. So the cutting list here would be nice if it had part numbers or part letters, because it would make more sense. And it goes through, but it covers every single component part. We've also got areas, volumes, and various other bits and bobs which are relevant to what's happening. Okay, I hope that's been useful for you. Now you can start embarking on those aspects as well. Up next, we're going to be looking at planning for making and risk assessment in the workshop. If you haven't already, then have a look at chronology, because it talks about how you need to keep everything in order. Thanks for watching. Like and subscribe to DTTV if you found that useful.